Before coming on the today's discussion, it is necessary to recap vector form of Coulomb's law. Vector form of Coulomb's law between the two charges, say Q1 and Q2, can be expressed as vector F12 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square unit vector R21. Also 1 by 4 pi epsilon naught Q1 Q2 by R12 whole cube vector R21. And in terms of position vector, it can be expressed as 1 by 4 pi epsilon naught Q1 Q2 by mod of R1 vector minus R2 vector whole cube into R1 vector minus R2 vector. The Coulomb's law in vector form that is given for the two charges only. Now, we want to find out the force on a single charge due to n stationary charge. For this purpose, we have to employ principle of superposition. Principle of superposition is applicable in different contexts. Here, we will use the principle of superposition in terms of force, which says force on any charge due to a number of charges is the vector sum of all the forces on that charge due to the other charges taken at a time. See the diagram. Q1, Q2, Q3 are the three charges with position vector R1, R2 and R3 from origin O. Now let O is the origin and Q1, Q2, Q3 and so on Q1 charges located at points with position vector R1, R2, R3 and so on Rn. Our purpose to find net force on charge Q1 due to Q2, Q3 and so on Qn charges. In vector form, we can write net force on charge Q1 due to all other charges is F1 vector equal to F12 vector plus F13 vector and so on. If we substitute the value of this here the vector which is F12 and F13 and so on, we will get net force on charge Q1 due to all other charges F1 equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 squared into unit vector R21. You may revisit the first slide and so on. It can be written as Q1 by 4 pi epsilon naught. Q1 here is common in all the terms. So Q1 by 4 pi epsilon naught summation I equal to 2 to n Qi by R1I square unit vector Ri1. It is the net force in terms of unit vector. Also, we can write in place of unit vector, we can employ R21 vector. Then denominator will be R12 cube. See the previous one, here R12 square. and so on. Again, in the form of summation, Q1 by 4 pi epsilon naught summation I equal to 2 to n Qi by R1I cube vector Ri1. Also, we can express the net force in terms of position vector. In terms of position vector, it will be F1 vector equal to 1 by 4 pi epsilon naught Q1 Q2 by mod R1 vector minus R2 vector whole Q into R1 vector minus R2 vector plus so on. Note equation 1, equation 2, equation 3 all gives the value of net force on the charge Q1 due to other charges. So all are same in different form. At last, use the principle of superposition to solve these two questions at your own. If any problem, then post that problem.